The metallic bond is very different from the two types of bond that we have seen so far, the covalent bond and the ionic bond. In metallic compounds, the atoms are very close to each other and form compact structures. In addition, they have their own characteristics, among which the high electrical conductivity stands out. This property, that of conductivity, depends on the electrons of the metallic bond having freedom and ease of movement. It is for this reason that for metals to have mobile electrons, they need two characteristics at the atomic level. The first is a low ionization energy. We have to remember that this ionization energy is necessary to remove an electron from the valence shell. The second characteristic is that they have empty and accessible valence orbitals that allow electrons to move easily. There are two theories to explain the freedom of electronic movements in the metallic bonds. These are two: the so-called theory of electron gas, or the sea of electron, and the theory of bands. In the theory of electric gas, also called the sea of the electrons or the electronic cloud, the metal atoms lose their valence electrons and form a tight cation network. Thus the cation form a compact crystal lattice, and each cation surrounds itself with the maximum number of neighboring cations. The valence electrons move freely through the empty holes in the lattice, forming the electron gas or the electronic gas. Freedom of movement explains very well the properties of metals, such as high electrical and thermal conductivity. It also explains ductility and resistance to deformation. Based on their electrical conductivity, solids can be classified into three groups: insulators, conductors, and semiconductors. This last property, semiconductivity, cannot be explained from the sea of electrons models. Another theory is need, which is band theory. This explains why metals are very good conductors of electricity. Some explains of metallic links are the following. For example, silver is used in jewelry and silver stores to make a great variety of ornamental and everyday household items, and with a lower degree of purity in costume jewelry. Cadmium lowers the melting point of the metals with which it is allowed. It is used with lead, tin, and bismuth in the manufacture of fuses for automatic systems, fire alarms, and electrical fuses and those things. Zinc is an essential mineral found throughout the body, but especially in the muscles. This mineral is important for cell division, wound healing, hair growth, regulation of blood sugar, and immune defenses and stuff. Palladium is used primarily in catalytic converters. It is also used in jewelry, dentistry, watch marking, and blood sugar test scripts, in aircraft spark plugs, and in the production of surgical instruments and electrical contacts. And these are more or less some examples.